Okay, so this is question 15. A student is asked to determine the resistivity of a metal in the form of a wire using a graphical method. Draw the circuit diagram of the circuit he should use and state any additional equipment that would be required. So, the circuit diagram, we need a wire, long wire, and we need to connect that wire using an ohm meter to the wire. We are going to need to measure the resistivity. If you remember, the equation is R is rho L over A. So we need to be able to measure the length. So he will also have a meter ruler along here, like this, to be able to measure the length of the wire, like that. And we'll also need to be able to measure the diameter of the wire. So they need a meter ruler, they need a micrometer, screw gauge, to measure the diameter of the wire. Okay. Describe how the measurements obtained could be used to determine a value for the resistivity of the metal. So we are asked to have a graph. It must be a graphical method. So the first thing that you need to do is plot a graph of the resistance on the y-axis against length on the x-axis. So you have a graph that looks like this. Sorry, L, not X. Length against resistance. Just make that a bit neater. Length against resistance. Now we have the equation that I've written over here. R is rho L over A. So we do have that the resistance is equal to rho over A times the length. So this graph will be a straight line through the origin. So we need to, because we plotted this on the y-axis and this on the x-axis, we should have a straight line y is mx. Now we can see here that the gradient of the graph is going to equal the resistivity over the cross-sectional area. So we need to be able to get the cross-sectional area to get the resistivity. So the resistivity is going to equal the gradient times the cross-sectional area. So how do we get the cross-sectional area? We need to measure the diameter of the wire using the micrometer screw gauge and find the cross-sectional area using area is pi d squared over 4. Measure the diameter of the wire D and find the cross-sectional area using A is pi d squared over 4. Now remember, if you can't remember that, that's the simplest way to measure the area, because you've measured the diameter. But of course A is actually pi r squared, but r is d over 2. So A is actually pi d over 2 squared, which is pi r squared. That's just as an aside, so that you see where that equation comes from. Okay, so state one precaution that the student should take to ensure the results are as accurate as possible. Well, there's a few things that they can do. To measure the diameter of the wire itself might not be very uniform. So they might measure it all the way along to see if it has the same diameter. So measure the diameter at 3 points on the wire and average. Find the average is one possible way. Or, if we look back over here, my wire itself might not be a perfectly straight. It could be that the wire is not very straight, it's a bit of a wobbly line. So you could also say you've got to make sure that the wire is nice and tight. That might be one way to do it. We could do that, or we could also do make sure the wire is straight. That's important. Okay, so those are some other ways of getting that mark.